This is Google Colab, a full Python data science machine that lives in your browser tab with free GPUs waiting behind a single click. No installers, no setup wizards, no hardware shopping. In the next 15 minutes, you will go from an empty browser to a trained machine learning model and every click in between.
Here is what you need: a Google account and any modern browser like Chrome, Firefox, Safari, or Edge. That is the entire list. Windows, Mac, or Linux makes no difference because all the heavy work happens on Google's cloud servers. No Python installation, no admin rights, no graphics card required. Your laptop is just a window into someone else's supercomputer.
Open your browser and go to colab.research.google.com. If you are not signed in yet, click the blue Sign In button at the top right. Choose your Google account, enter your password if asked, and you land straight on the Colab Start page.
The Start page opens with a dialog for creating notebooks. Click New Notebook in the bottom left. Colab spins up a fresh notebook and saves it automatically into a folder called Colab Notebooks inside your Google Drive.
Let's take the 10-second tour. Cells are where code and text live, and this play button runs whatever is inside. The toolbar holds your save state, the undo arrow, the cell inserter, and the move tools. On the far left sits a panel of icons: table of contents, files, variables, secrets. Click the notebook title at the top to rename it anything you like.
By default, you get a CPU-only runtime. To unlock the free GPU, open the Runtime menu and choose Change Runtime Type. In this dialog, pick T4 GPU from the Hardware Accelerator dropdown, then hit Save. Colab reconnects you to a brand new machine with an NVIDIA Tesla T4 attached.
Time for first contact. Type this into the first cell and press Shift-Enter to run it. The spinning icon means it is connecting to a fresh cloud machine. After a moment, the output prints your Python version, proving your browser is now talking to a real computer in a Google data center.
One cell can verify everything. Check the Python version, ask Pandas and NumPy for their version numbers, and run NVIDIA-SMI to see the GPU itself. 18 gigabytes of memory available on a Tesla T4. That is a serious card sitting at the end of a URL.
The environment ships with the classics pre-installed, but sooner or later you need something extra. Install any package with an !pip install command. The exclamation mark sends the line to the shell instead of Python. Pin versions when reproducibility matters, and remember, installs vanish when the session resets, so keep them at the top of your notebook.
Your notebook is ephemeral, but Google Drive persists. One line mounts your entire drive into the file system. Run it, and Colab asks for authorization. Click through the account chooser and allow prompts, and your files appear under Drive/My Drive. Anything you write there survives, even after the runtime shuts down.
Now bring in data 3 ways. Upload small files straight from your computer using the Files panel. Pull bigger ones from a server with wget, or read a CSV directly off the web with Pandas. 3 sources, 1 destination, the same read CSV call.
With data loaded, Pandas does the heavy lifting. Head shows the first rows rendered as a clean, sortable table right inside the notebook. Info reveals column types and missing values. Describe summarizes every numeric column, and value counts breaks down any category instantly.
Numbers hide patterns that pictures reveal. Matplotlib charts draw inline below the cell, build a figure, plot your series, add labels and a title, then let the Run button paint it. Every element is generated by code you can tweak and rerun in seconds.
Analysis complete. Time to keep it. Save your process data frame into your mounted drive, and it stays safe after shutdown. Need a local copy too? Files.download pushes a file to your computer, where it lands in the downloads folder like any other download.
Colab can turn comments into controls. Start a comment with an @ title, and it becomes a header. Add at param, and the cell grows sliders, drop-downs, text boxes, and date pickers. Drag the slider and rerun. You just built an interface without writing a single widget. Magic commands unlock hidden powers. %% time measures exactly how slow or fast a cell is. %write file exports a cell to a real Python file on disk. And %HTML renders live web content inline. They look like comments. They behave like superpowers.
Never paste an API key into a notebook you might share. Open the key icon in the left sidebar, add your secret, and give Colab permission for this notebook. Then one function call fetches it invisibly at runtime. Safe in your account, invisible in your code.
2 more panels worth knowing. The variables panel lists everything alive in memory, name, type, shape, size. And for big tables, an interactive library turns static output into a sortable, scrollable, searchable grid with one line.
For deeper interactivity, there is ipywidgets. A slider bound to a function rebuilds the output live as you drag. Watch the curve reshape in real time. This is how you turn a static analysis into a tiny interactive app.
Colab renders rich media natively. Display images from disk or from a URL. Play audio straight into a player. Even embed video. Outputs are not limited to text and tables. Whatever your analysis produces, the notebook can show it.
Real-world data comes over networks. Use request to call any public API, check the status code, and parse the JSON payload. Here we pull exchange rates, walk the nested structure, and pull out the exact number we need. That pattern works with almost every API on the internet.
Everything so far was warm up. Let's train a real neural network. Load MNIST, normalize the pixels, stack a small model, and fit for 5 epochs. Watch the accuracy climb past 98% entirely on Google's free hardware. You did not install anything. You just trained a neural network in a browser tab.
Your finished notebook is portable. File menu, download, and grab the raw IPython notebook file, a plain Python script, or a formatted PDF. Share it, commit it, or hand it to anyone who wants to reproduce your work.
Colab speaks GitHub fluently. Any public notebook can be opened by swapping the domain in its GitHub URL, or by clicking the Open in Colab badge. When you're ready to push back, the file menu saves a copy straight to a repository as a commit.
Sharing works like Google Docs. Click Share, type an email, set the role from viewer to editor. Collaborators appear as colored cursors, and everyone types in the same notebook at once. Comments and suggestions included.
Every Colab user meets these errors eventually. GPU quota exhausted? Wait for the rolling 24-hour window or switch to CPU. Session crashed after using all available RAM. Free tier gives you around 12 gigabytes, so process in chunks. Pip install failed? Rerun the cell, pin the version, and check your spelling. Each error has a short, boring fix.
3 more quick repairs. Drive mount failing? Rerun the cell and redo the pop-up. File not found? Check the exact path, content/your file name, and refresh the Files panel. Secrets throwing a key not found error? The secret exists, but is not granted to this notebook. Open the panel and flip the toggle. Fixed.
Colab also carries an AI copilot. Click the Gemini Spark in the footer to chat about your notebook, generate code, and explain errors in plain English. For larger jobs, describe what you want, and the data science agent builds the whole multi-step analysis for you. It can even build charts from a plain sentence. AI features need an account flagged 18+, and may vary by region.
How much does all this cost? The free tier covers everything shown today. Pay-as-you-go adds 100 compute units for $9.99, valid 90 days. Pro is $9.99 a month for better GPUs and longer sessions. Pro Plus at $49.99 adds background execution. But honestly, start free. Today's entire project ran without spending a cent.
Look how far you came. From an empty tab to a trained model, with packages, data pipelines, secrets, sharing, and error fixes along the way. Everything ran on Google's dime. Subscribe for the next tool manual. Drop a comment with what we should cover next. And happy analyzing.